All right, so welcome everybody to the Google NYC Tech Talk. This is part of a monthly series. We've had several, we're about a year's worth into the running at this point. We've had them every month. We thank all of you for coming. Just want to give a couple of quick fun facts about Google NYC, the office that a handful of us work in and very much love. So this building was originally owned and built by the New York Port Authority, and built it in 1932 as a warehouse. At some point along its life, it's also acted as a bus terminal, hence the Port Authority. In fact, one of the coolest features about this building is the elevator that's right behind these two large screens over here. Each of these elevators can hold a bus. And they can move a bus from street level up to this floor and probably a lot higher than this floor. From what I understand, what they used to do is they used to put a bus, move the bus up, put people on the bus moves back down, bus leaves the building. If we're lucky, these elevators that are still in use, I don't know what they actually move in them, but they still use them. If we're lucky, they'll use the elevators while we're in here, and we will get to feel the elevator doors opening and closing, at which point the entire floor will shake. It's good fun. But anyway, it was built by Port Authority in 1932. It's the second largest building in Manhattan in terms of total square feet. It runs all the way from 8th Avenue to 9th Avenue, 15th Street to 16th Street, so it's an entire city block. So even though it's only 15 stories, and the top floors are not as big as the bottom floors, it's the second largest building in Manhattan in terms of total square feet. There's about 3,000 Google people that work in NYC, both in this building and in Chelsea markets across the street. Google, prior to being in this building, used to have an office in Times Square. One of the more fun or ridiculous things about Google, depending which way you want to look at it, we are never more than 150 feet away from food. In this building alone, there are 4 cafeterias. One of the cafeterias has a truck in it. And then within each floor, there are also micro kitchens that have snacks. We are never more than 150 feet away from snacks. The running joke is that when you join Google, you gain 15 pounds.
Is it true you're going to get rid of the segways so you have to walk?
We don't have any segways in this office, but we do have scooters, as you can see from this particular picture, so at least we get some exercise riding the scooters. In fact, I'll give you, since somebody was asking about the weight, when I joined Google, I was told that the biggest mistake that I could make is actually buying clothes day one. I should wait until 6 months later and buy clothes that are 4 sizes bigger, just so I would fit in them, right? That is the Google 1520, but don't bother buying clothes because you're going to gain the weight. Buy clothes that will fit you in your new size. It wasn't advice about how not to gain the weight. It was advice about you will gain weight, accept it, move on with life. All right, so we're hiring. Google NYC has grown. Every time I put the slide up before the number, the 3,000 number changes every time we do this. If you're interested, there are various different people here that are wearing Google shirts, kind of like myself. I'm with the engineering organization. So if you have any technical questions, you can ask some of us engineers. There are a handful of us here. But there are also a handful of people here from the staffing organization that are here in the back. Some of the green shirts. Howard is also back there. Feel free to catch up. And here's some fun pictures about what the office is like. We have scooters, we have game rooms. Every now and then we have fun events like that faux sparring thing that you see. There's more pictures of the office. More pictures of the office. There's a huge partnership between Google and Lego. Not really sure why, but Lego is a huge theme within the New York office. For example, the Google logo up there is made by one Lego squares. The building is made out of Legos? Oh, the red building, not the physical building. Got it. Yes, that is true. That one is still around. That one is still around. So today's agenda. We are in the 6:30, 6:35 slot. I'm doing an introduction. The real talk by Cory will be 6:35 to 7:20-ish. We will do about 10 or 15 minutes worth of questions after that. if you guys want to walk up to the microphone so everybody can hear. And then we'll do about 20 minutes, 25 minutes worth of informal QA, whatnot afterwards, but we do have to be out of here by 8 o'clock. So at 8 o'clock, we will ask, we will stop serving alcohol. We will ask everybody to leave because there's a hard stop at 8 o'clock from our security team. Okay? Want to introduce you guys to Cory Smith. This information that's on the slide has been posted to the Meetup site, so you guys, I'm sure, have all read it. But a couple of informal notes. Cory and I have been working together here at Google. Cory has joined Google since at about 2008. He's been here for about 3.5 years. First job was on Gmail, helping with JavaScript tooling and JavaScript testing for the Gmail team. After about a year or so, he moved over to the Docs team and has been working with the Docs team ever since. So I hand it off to Cory. Thanks very much.
Okay. So the predictable question is this thing on? Oh, apparently so, okay. And the next question is, where's the mouse? Yeah. All right. I think that worked. Excellent. Okay, so before I start, JavaScript testing at Google is big. It covers many domains: infrastructure, tooling, developer experience, techniques, refactoring. All right, technically that goes under techniques, but when you get right down to it, dealing with legacy JavaScript is an entire domain unto itself. Obviously, I will not be covering all of these in an hour. I'll be focusing mostly on tooling because that's where I have a lot of my experience. So let us move on, see if this works. Excellent. Let's first set out the problem domain we're dealing with. Actually, there's a problem that kicked in before I even managed to get, say, the slides written, which is on the abstract. We're trying to come up with examples of proper JavaScript applications. So how many people here can come up with a classic popular JavaScript application? By application, I mean something that starts when you load a web page and persists on that web page, updates, go through several different states, basically a classic desktop application, but entirely in your browser. Let's call a few out here. Anybody? Gmail, okay. Maps? Twitter, not so much, because Twitter, it does load and so forth, but it doesn't actually do much. It just gets updates. It doesn't really go through a lot of states. So I'm sketchy on Twitter. Maps. Right. So you notice that predominantly most of these are Google applications. Yeah, that was my problem, because it actually took me a while to come up with like Hipmunk. And then, of course, I'd forgotten the original one that started all of this, which is Microsoft's Web Outlook. That one I totally forgot about. But without that, we wouldn't have most of the applications we're dealing with today. So the problem we have with JavaScript and testing it starts with the language. This gentleman here, I'm going to totally mispronounce his name because I've never heard it said, Robert Kaliau, worked with Tim Berners-Lee on, developing pretty much what we have as the internet today and so forth. And he points out the fact that JavaScript is a mess. So a little bit of history here. JavaScript was first developed actually brought to life in the late part of 1995, and it was called MochaScript LiveScript at Netscape by Brendan Eich. And it actually became JavaScript due to some licensing and some agreements with Sun. And the idea is that JavaScript would be the sort of child language, much the way VBScript is for the Microsoft family of products, allowing scripting in Sun setup, which is why, of course, it has the curly brackets, braces, and semicolons starting out originally, because Brendan had come and he'd been told that, and why he joined Netscape and why he did this is he was told, you get to put Scheme in the browser. Well, we got JavaScript instead, which borrowed heavily from Self. Another one of his statements was he couldn't put in, say, classical inheritance because that would have kind of pissed the people in Java off, so he went with prototypical inheritance, which is still causing problems for many developers today. And so after that, the ECMA standardized, and it became called ECMAScript in '97. And what that gave us was, well, the reason why it wasn't called JavaScript is because of those legal issues and copyrights that came up. But since then, we've gotten pretty much every year some sort of backwards compatible version of JavaScript. Mostly this, came out of Microsoft with JScript, which happened on a pretty continual basis. And it stayed pretty much stagnant. People added little bits and pieces. There was the whole DHTML thing with layers out of Netscape and all the rest of these fun things. I mean, I still miss Netscape 4.7. You have to love a browser you can crash by putting CSS in a table cell. It was incredible. And then in 1999, IE5 rolled out with a cute little feature in an ActiveX component called XML HTTP request. And this was done entirely to support the Outlook web client, which was pretty cool. I actually used it at one point. I was like, wow, this is impressive. Of course, I was writing JavaScript at a time, and 2007 was when I was working with that, so I was a little late to the party. But nobody paid any attention until about 2005 when the gentleman at Adaptive Path came up, slapped a brand name on it that was close to a household cleaning product, and suddenly we ended up with JavaScript being treated more or less as a real language. But back to the language itself. According to Wikipedia, which we know is unbiased, 100% true, provided it isn't about me, JavaScript is a prototype-based, object-oriented scripting language that is dynamic and weakly typed, has first-class functions. It is also considered a functional language like Scheme or OCaml because it has closures and supports higher-order functions. So what does that mean for testing? Well, first off, it means that with weakly typed, you now have a maintenance nightmare. Because every time you change your source code, well, you change this core library here, and somewhere else, something else comes in, and suddenly you get the rough equivalent of a null pointer exception. Or my personal favorite error message, error at line 0. Thank you, Microsoft. No stack trace involved either. But there are a couple of sort of gotchas in here, and for those of you who are actually familiar with JavaScript, I'm sure you'll recognize this. So I'll bring up the next slide, and if anybody actually wants to explain it, the mics are there and there. So we're gonna look at the first thing, which is equality. Okay. Can someone? All right. What's the catch here? What's the name of what I'm about ready to show you with primitive comparisons? Nope, not duck typing. Coercion? Yes, type coercion, because this is true. If you consider the black duck, which is the number 1. Always love the black duck. And then the teal duck, which is, of course, the string of 1, equals, they equal each other. This comes as a slight surprise for many people. However, 2 black ducks can triple equals, or definitively without coercion will equal each other. But 1 black duck will not definitively equal 1 teal duck. Well, this usually catches new programmers off guard. Most people get used to this, but this does bring up some strange effects in managing a large-scale application, because if you pass a string of 1 through, well, it equals fine, but if you attempt, and if you pass the number 1 through, it does the same thing, but they have different methods on them thanks to duck typing. It was someone in the back calling out, because, if it looks like a duck, it quacks like a duck. So it gets more fun with equality, though, because equality doesn't always do what you think it does in JavaScript. There's one of these classic little setups here, and this is taken from the V8 engine, and it follows the ECMAScript 5, and it's showing exactly how much fun you can have with type coercion, because developers a lot of times will cast to a true or false value by using bang bang or exclamation point. And as you can see here, it equals true. However, it's not the same as doing an if statement. The actual section of the spec that talks about this is the unary negation operator, exclamation point, is defined to apply to Boolean abstract operation while equals is not. The to Boolean abstract operation returns false for undefined, null, false, 0, -1, and nan, which is not a number, an empty string, or true for everything else. This is not the same as you'd expect. Which brings us to the next particular concept that comes up, which is truthiness. I was vastly amused by getting hit upside the head with this one recently. But truthiness, as you can see, was first defined at the Colbert Report. Comes from the gut, not from books, which might explain a few things in a minute. Or the American Dialect Society, preferring concepts or facts one wishes to be true rather than concepts one knows to be true. Or as someone brought up to me recently in a bug, a common JavaScript term that means any value that if the if branch is taken. Yeah, I need to update the documentation on that one. So that's the basic of type coercion, but type coercion only really applies to primitives. What gets fun is when we consider complex equality. Now we're dealing with ducks, folks. We're in the ducks. Because they're both instances. Nothing's been modified about this. We have the blue duck, we have the red duck. However, the catch here, and I love this, is they do not equal each other. This is why when I first started working on testing and tooling libraries for JavaScript, I found what I thought was the definitive function that sums up JavaScript as a testing language. It's an assert called assert object equals. Its sister function, assert array equals. These only exist because you have a suitably weakly typed dynamic language where you don't actually know what you get until you check each piece. So what essentially happens here, if you'll follow the simile, is we have to go through and count each feather on every duck, make sure it has a beak, 2 eyes, legs, wings, blah, 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 to ensure that they're actually equal objects. This is kind of cute the first time you see it, and then a pain in the neck every time after that, because you also have to effectively walk your object tree in memory whenever you want to know. There's no shortcuts here. Luckily, JavaScript does tend to make doing that kind of introspection easy because every object in JavaScript is essentially a map. I'm not going to get into explaining this. I am somewhat limited on time. But what it brings us to now is another important concept, which is pretty much necessary in any testing language that you deal with, and that is mocking. So JavaScript, there's a couple of different schools around here. One of them is, why do we mock anything in JavaScript? Well, after you set up a situation where you're making a XML HTTP request to an actual live server and expecting certain kinds of data back, it suddenly makes a lot more sense in order to make the test smaller to actually replace your network layer with something a little more easier. The other thing that came up not long after getting through this particular argument was, why do we need mocking in a language that's so declarative and easy to write ducks in? Because, if it looks like a duck, it quacks like a duck. And so here we have, somebody comes along and they make a duck. We've got our nice little duck here and so forth, and everything works fine. Okay. All right, maybe everything works fine. And then, so the initial substitution and setup is very easy. However, the problem is when your fundamental duck changes over time, say it quacks differently, your mock does not. Most good mocking libraries will actually detect and look for changes like that. However, since JavaScript is so loosely typed, it offers a bit of an issue surrounding, well, making sure the arguments are the same type that they go in without actually working against the implementation. So obviously increased unit test coverage becomes a necessity. And then sort of the final thing to deal with as a challenge for the whole problem domain of JavaScript testing is your friend and mine, the DOM. You see, the DOM offers an interesting difficulty here because once you have all your ducks set up and you've written and you've gone through and you've written your things and you've pulled it up in a browser and everything else, well, then your problems multiply because you're not writing for one runtime, you're writing for usually at least 5, in some cases multiple versions of one particular runtime. It gets needlessly complex. These are one of those things that comes up continuously about JavaScript in terms of testing and handling and maintaining long term. Because JavaScript was great when you just wrote a page and you used it in an on-click handler to change the color or pop something in. But when you start having code that's being worked on by many, many people and everything else, it starts to become more difficult. Does anybody remember the, I can't remember the name of it, I believe Yahoo bought them, but there was a particular client, it was a mail client, that basically duplicated everything you could ever ask for in your entire productivity suite in terms of email, calendaring, and everything else. Yes, Zimbra. They had I think they had 100,000 lines of code, at least. I remember going to a talk and I was just in awe that they hadn't torn all their hair out by now. But they managed to do it. They basically wrote an operating system inside it and then ran with it. It was very impressive. So now that we've got the fundamental issue we're dealing with JavaScript, why is JavaScript so different and important with Google? Well, most people know that Google has 3 main languages, right? We've got C++, we've got Java, we've got Python. And we've got JavaScript coming along. Why is JavaScript important enough that they'd actually start hiring people like me to come in and write tools for them? Well, this. You see, the red line is is C++. The green line is Java, the blue line is Python, and you see the hockey stick there, or the sort of hockey stick? Yeah, we get a lot of JavaScript code, and we've been building it fast. This made things a little dicey here and there because there's no support. Nobody took it seriously. It kind of snuck up on the tooling efforts and everything else in order to see where JavaScript would go and so on. So what do we do to make a difference with this? Well, we start looking for solutions. Well, solutions, sort of, Let's see what we got. The first part about Google is that the testing infrastructure, the build infrastructure in here is incredible. Just straight off, there's about 1,800 builds. This data is several months old. There's about 1,800 builds. There's 120 million test suites inside the code base. Of these, 7.5 million test suites containing 60 million tests run daily. So we're dealing with serious scale, and the build system supports this. Now, this is for all languages. What are we doing when we deal with web testing? And this covers Selenium, this covers, all the different integration tests, as well as our unit tests and so forth. Well, we've got the browser-based tests come up to be about 1 million tests a day with about 1,000 concurrent browser sessions at a time. The affected tests run on every check-in into the code base, except when it's being throttled because somebody's doing horrible things with resources, which I'm usually guilty of. In each of these tests gets a deterministic environment, no matter where it is. You're assured that the browser will start up the same way. You will have the same libraries in your Windows instance, the same libraries in your Linux instance. You will have a deterministic environment to work in that's basically hermetic. And then all of the logging from these is then pushed into one central place to work off of. So you'll notice that I left an environment out there. It's not on the slide. I said Linux, I said Windows. What's conspicuously absent here? Why would Mac be absent? Because you can only virtualize Mac software on Mac hardware legally. So we actually don't test against anything other than Safari on WinXP. Luckily, it doesn't tend to cause too many problems. And, we just sort of, it's one of those gaps that there's not much we can do to really get rid of. But that's the kind of infrastructure we're basing on. There's actually a very good, there's a couple of talks that I put at the end of the presentation that talk about the build system and how it gets there and all the crunchy bits of infrastructure, as well as how the web testing works as well. I suggest you check them out. The web testing is from the GTAC last year. So now that we know that we can actually run the tests, we have to look at what we're actually running. And that brings us to the common JavaScript development cycles. Now, the first way that most people start out writing JavaScript, and the first way that most of the tests are written, are something I like to refer to as demo pages. They're effectively manual integration tests, and they work out really well when there's one duck. When you got a flock like this, it gets to be a bit of a problem. Because what you do is you add and tweak your code, your code a little bit. You go to the browser, you hit refresh, then you debug. And it continues on this path continuously. Or there's even the worst case scenario where you start your server and then you do that through the server. So you're running your full application, including your Java stack, continuously at all points in time. Now, this was pretty much the way JavaScript testing started out, and then, as complexity rose, more engineers came in, and we ended up with unit tests, where you take one duck, you load it up in the browser, you refresh it, you get to see what works. This was actually originally done by the original JS unit, written by Edward Hiate, which it apparently was abandoned around 2006, and it actually won't work on most modern browsers. If you ever take a look into it, I've never seen so many frames in my life. There's no XHR or anything else. It's entirely frame-based, which means finding the window and debugging your test is a tremendously, tremendously painful thing to do. Well, some clever developers came in and they said, this isn't really working for us because we're spending too much time messing around with this JS unit stuff. And so we have Clojure. How many people here actually know what I'm talking about when I'm talking about Clojure? A couple, handful here. Clojure was, the first Clojure check-in, I actually verified this, was in 2006. And this was after the release of Gmail. Gmail pretty much spawned the Clojure libraries. It was open sourced in 2009, and when it was first open sourced, it was incredible fun to read the blogosphere because there were numerous comments about how verbose the code is, how slow it was, and a huge amount of really, where's the magic in this code? Well, it turns out there really isn't any magic. Most of the tricks that are included in Clojure are dealing with the same problems other libraries had already dealt with, on top of the fact that they had a lot of different concessions towards maintainability. The Clojure system, if you look at it, kind of pisses a lot of JavaScript programmers off because it has almost Java-like syntax in order to handle each type. Now, this seems like a huge amount of waste of time and effort and so forth to put in, except what it really does is it's invaluable when you have to actually dig through the code. But one of the things Clojure put out that almost nobody noticed is how much testing support it has. It has a full, well-established mocking library. It is tragically based on, what is it? Not JMock, it's the other one. SimpleMock or whatever it is. Which will offer you matchers and everything else. It's your standard replay mocking system where you create the object and you put in all the different calls that you expect off that object, and then you say replay, and then you pass in your dependency, and it handles it. So let me take a quick question here. Does anybody not understand what I'm talking about when I'm talking about passing in dependencies and mocking out objects? It's okay. Good. I'll keep going. It also offers the necessary matchers, which when you're dealing with assert object equals, sort of nonsense of having to know what type is coming in so you can actually do comparisons on that type, is pretty much necessary. It also provides a full set of fakes. Now, mind you, it calls them mocks, but if you're going to split hairs, which some developers do, I can't imagine who would do something like that. But it handles things like the set timeout. There's an entire existing, sort of network replacement piece for handling XHR calls and so on, which is invaluable when taking your asynchronous code and then turning it into a perfectly reasonable, fast-running unit test. It also has the full set of asserts that you'd expect, including my personal favorite, assert object equals. And then it has some standardization functions necessary for proper DOM testing. Things that will, get CSS rules and figure out which styles are applied to a given object, as well as normalizing small things like color. How many people here have actually tried to pull the color of a JavaScript object in a cross-browser environment off and compare it? Yeah. You've noticed that in some cases you'll get back exactly what you put in, which would be your hex value, pounds, 3 to 6, what is it? 3 to 6 different numbers. Or you'll get back a string that says RGB, parentheses, your RGB values, comma separated, end parentheses. So something that cleans this sort of thing up is nice. There's also, other functions to clean up and standardize your HTML, like trimming off white space, getting rid of some of the wackiness in terms of capitalization, as well as introducing new attributes. Generally fun things. But the real value that comes out of Clojure is the compiler. You see, one of the things that went out and why this information is so verbose and why Clojure code is so thorough and set up is that it goes through a compilation process. And this compilation process does things like, your syntax checking, so you know that you really did actually finish putting in all your parentheses. It's a little slow to use it for that. Mostly, you look for an IDE on that to work it out. It also picks out the warning of dangerous patterns, like, say, using this in a confusing context. Outside a class is one of those. When you haven't documented it, it might actually be part of a method. This is one of those delightful things that JavaScript inherited from self, which is where the context of the function in which it executes is actually completely dynamic. It depends who happens to be owning that particular function at that given point in time. It's an absolute joyous experience to debug, because you open the debugger and you're like, who is this? Unless somebody actually filled out toString, you're going to have a fun time. It also, looks for things like, checks your dependencies and your types. The types is perhaps the most important part, because it goes through and it reads all of the given pieces about what's acceptable to go into a function, and then it compares them against what you're actually passing in. So, obviously there's certain places where this doesn't work, but once you reach a suitable size, it can actually look at an application and say, yeah, no, you're passing in the wrong type here, and warn you about it. Finally, what it does is dependency checking. This is more for production code, because it has the actual universe that you're going to be running against, and it will go through and it'll verify that each dependency that you are using in your code is actually in your code. So this cuts down the number of times when you start up your application's running, and all of a sudden it comes to a complete grinding halt by throwing an exception about trying to call, foo on null, which is always a great experience. Or even, this object, which if you're lucky will actually have the object or representation of the object, does not have method foo, except in IE, where it just gives you all sorts of weird fun stuff. But what this brings us to is the next thing, is I really have to stress this, because once you have all your ducks in a row, all lined up and ready to go, compilation comes along and finds that one. The one you didn't actually think was going to be that way, but, it finds the important pieces, and it also checks for cute little things like using bit operations when you meant to use a Boolean operation. Say, 2 pipes and using 1 pipe instead of 2, or 1 ampersand instead of 2, which is rather important. So I've talked a bit about Clojure. Now, what actually did Clojure offer to testing? Well, what we got there was the Clojure HTML test. The Clojure HTML test is based off the JS unit test. So the way you set it up is you write an HTML page, you stick a head in, you put at the top of the head, you say include the Clojure base file. Then you include your deps file. The deps file is comfortably generated, usually by a Python script. You saw that Python was still holding on there, was still holding on in there, mostly because it's used for internal scripting. There are still applications written in it, and it does an absolutely excellent job where it's used. But what happens in this particular case is there's a script out there that will generate these deps files for you. What the script does is it goes through, iterates through your entire source tree. It finds all of these cute little statements that are put into Clojure code. One of them is goog.provide, and then a symbol name, which is usually the namespace and the actual class you have. And the other one, and this is the important one, is goog.require symbol. It will go through and it will basically make a mapping between the location of that file and the symbol, and write it into a JavaScript file. Then when you load it up in a browser, it gets the Clojure base, which defines a whole bunch of necessary Clojure functions like provide, require. And then it'll load the deps file, and suddenly it knows about your dependencies. And then as it's going through and parsing the document, what happens is every time it hits a script section that has a goog.require, it calls this function which uses document.write and adds a new script tag to it. Now, I know document.write is evil. We've all heard this and everything else. But this is one of the few times where it actually works the way you'd expect it to. Is that because new script tags are getting added to the document, because document.write even exists, you are assured when a web page loads in pretty much all browsers that that script will execute before the next script in the document. There's a caveat in this, mind you. I've learned from personal experience, IE doesn't always respect when a vast number of document.writes are called. So sometimes we have to move things up and down out of what we consider to be the best order to make sure that IE actually called the scripts in the right order. It's deterministic, but it's weird because it doesn't happen all the time. It's one of those really weird, odd bugs that comes up. The end result for the developer is that in this test, you can now get your dependencies when you ask for them. It just imports it in. It acts like any... I do not work for the Chrome team, in case anybody's asking. All right. Yeah. The rest of the presentation will be done with hand puppets. Not really. Not really. There we go. All right. So now I will not demonstrate the security features involved with logging into a corporate account. However, the last person who logged in should really have never clicked the keep me logged in permanently. It's a shame there's not actually more fun I can have with that. So, so what are the other advantages of a closure test? Well, because it's in an HTML page, it is fully accessible. It has, basically what you'd expect from a developer standpoint, which is it can pull in, it's very easy to add new dependencies to. Excuse me. Slightly out of order, two things at once, not exactly my greatest thing. It's a complete HTML page, which means you can add whatever DOM dependencies you need fairly easily. It's just a simple declaration. You put in what you want there. Because the test case is effectively an HTML page, it will always be cleaned up. So your entire JavaScript context is cleared out every single time you run the test, which is highly beneficial, though it does encourage certain questionable coding practices. The other fun thing that comes in and is interesting in this particular case is you can perform arbitrary dep ordering. So you can put a script tag with a couple of Google requires in it. Then you can put a script tag that pulls in another resource that loads before, say set some global variables, and then you can put another script tag with a couple of Google requires in it. What these allow you to do is to take your production code, set some variables to it, and set some variables to it, and then load the rest of your production code, allowing you to create the exact environment you're looking to do with testing. Obviously, this is generally a net benefit for the, as we fast forward through time here. Hey, you got to see a presentation and a half. How many people can say that? If I can actually get up to it. There we go. And then, yes. Oh, no, one more. Come on. Speaking of getting your ducks in order. Yeah, I'm using the Chrome icon still. You can also open a closure HTML test without a server involved. So you can just take it, you can open it from the actual file system, which turns out to load rather quickly because most browsers have a limitation about how many sockets they can have open. IE is somewhat infamous for only allowing 4 at a time, unless you go in and start flicking registry preferences. And Firefox has a much more easy registry to get to, but the same deal of flicking them. I'm not sure Chrome ever had too much limitation on it, though it does bring up the interesting question of, DDoSing a given website if they're a little casual with how they set things up. So what are the disadvantages to dealing with a closure HTML test? Because closure HTML tests were pretty much written and in pretty good form by the time I came to this. But I saw some points for improvement. Well, one of them is that you have to separately test each browser for development, as established by your HTMLized duck with your browser here, is because you're opening each page individually, so you still have that thing I pointed out earlier with a flock of browsers to deal with. You constantly have to do a context switch from your IDE to the browser. It's just a given. Typing away, wait, will this work? Flip over, run your test, flip back. Oddly enough, depending on how many windows you have open, that can take some time. There's also the delightful browser caching issues. If anyone's been doing development like this, you bring it up, you make a change, you flip it over, it's like, wait, the test is still failing, but I know I fixed it. You go back, you try it again, it's still failing. You flip open debugger, you finally look at it like, wait, this is the code I had 5 minutes ago, because it's cached in the browser. The browser has done a brilliant job of taking care of that for you. So now you have to remember to hit Control Shift F5 or Control Shift R or Command Shift R or whatever it is, or go in and modify the browser to make sure there's no caching whatsoever. Remember setting IE down to having absolutely 0 megabytes available, except it always ensured I had 1. It wouldn't let me go any lower. It's like, really, is my browser experience that important to you? Also, this HTML doesn't. It's a lot of boilerplate. It doesn't even matter if your test involves HTML or not. I'm creating a function to handle entirely mathematics in a class to do, advanced computation about sharding to different servers, and I still have to write HTML. That's not really that useful to me. It's hard to compile. That wonderful Clojure compiler I'm going on about, saying how wonderful it is, and it checks all these things and ensures that all your code works together, doesn't work. Because what do you know? If you give a JavaScript compiler HTML, it kind of has a problem with it. I can't imagine why that would be. Must be an oversight, the compiler, of course. Actually, I had an interesting chat with them, and they suggested that I work on extracting the JavaScript from there so we could do compilation on that. But that introduced new problems because if you recall, I said something about being able to include arbitrary script tags and arbitrary things, which meant now you're dealing with tests all the way across Google that pull in random stuff. One of my first 20% projects was trying to figure out how to make these tests run faster. A good portion of the time in running the test was actually spent doing document.writes. I think the highest I saw was something like 450 external script tags getting pulled into one document. Believe it or not, your browser can do that. And this is before, like Chrome came out and everybody started stacking as much as they possibly could inside a browser. And finally, it's really hard to lint. Most of the time when you run a lint over an HTML file, it gives you HTML lint errors. Funny thing that. So we know that Clojure has some development issues that comes in. So how do Clojure tests scale? Because remember, we're running like 1 million tests a day, 1,000 concurrent browser sessions. Oddly enough, Clojure tests actually scale pretty well. The thing is, it is a mapping of one HTML file to a browser, so we're dealing with this. Luckily, you can batch your HTML files up and so on. It does a pretty good job of managing our scale issues. However, it's got a few problems. You see, again, it's that pesky which dependencies actually go to which test. Because these tests allow pretty much whatever declaration of them, and the way the build files are set up, people will go in and they will get a huge glob of HTML files and a huge glob of possible dependencies and data dependencies to pull in, and they'll just throw it all in one particular build target. And then we'll execute that. Now, from an automation point of view and tooling, it's kind of a pain because we actually want to know exactly which dependency we have to send with which test. We can't really break these tests up. They're saying, oh yeah, there's a huge glob over there, a huge glob over there, just take them all and throw them there. Oddly enough, that can take up quite a bit of network space, especially if you take in, internationalization, where you multiply your number of HTML files, your number of JavaScript files by the number of languages. It gets ugly and messy. So from an automation perspective, it's a non-ideal solution. Mind you, if you go to a bunch of developers and say, look, what you're doing makes it hard for me to automate on it, they're just sort of like, what? It's a test. Yeah, not exactly a grand situation. And then there's the flakiness issue. So let's take a look at our stack we have to do to run an automated test. Well, we start with our VM, which is our baseline, because we have to match whatever OS we're working with and make it hermetic. And the VMs run inside these big scheduling processes and everything else that figure out what's running where. And they have, in some cases, slightly flaky amounts of memory. Now, for dealing with, Java and all the rest of them, this isn't a big issue because you're not really stacking, you're not really putting much more on top of it. We take a VM, then we put a browser on top of the VM. Now, browsers, they're great. They don't crash that often, right? However, if you take a browser and you do the same thing 1,000 times, 5,000 times, 10,000 times, a couple million times, oddly enough, they start to show some deterioration about doing the same thing over and over again. It doesn't matter if the environment's entirely hermetic and everything started the same way. There's that uncertainty principle that's unique for web developers, where you go, really? What happened here? I can't even get a reasonable stack trace. And then on top of this, we put Selenium. How many people here have used Selenium, especially before it became Selenium 2 WebDriver? Yeah, you know what I'm talking about. Selenium, when you start up and you run 1,000 times over, will probably, I don't know, maybe about 2-4 times, give or take, a couple 10 or so, screw up. And it'll screw up in a way you can't quite figure out what's going on because Selenium is a bunch of JavaScript running in one window with a frame that's now running another window to run a bunch of JavaScript, specifically your test. Now, with most applications, this isn't a big issue. But let's take a look at one of the unique properties of a JavaScript test. It doesn't, if it's not an asynchronous test, which most tests aren't, it basically pegs the processor. All it does is as much work as it can do in one JavaScript invocation. Now, most test runners have to take a break here and there because there's that cute little thing that pops up. It says, oh, this particular thing is causing your test to run slowly. Yes, it is. It's because that's exactly what it's supposed to be doing, is exercising all the different code paths that are involved. Now, the way the Clojure-HTML tests work is they'd start up Selenium, they'd open a page, and they'd continually poll against Selenium to say, are we doing, how we're doing, are you done yet, are you done yet, are you done yet? And the problem here is Selenium, the Selenium remote control, can't really tell the difference between, oh, I'm not done, and this. Yeah. The Selenium tests return timeout for, oh, I've done too much execution. Oh, the browser just went away. Oh, I've now stuck in a recursive loop. Oh, we never actually exited that while loop. All of these get the same argument of timeout. So is it any wonder when most developers look over and they see what comes back out of a their build goes red. They look at it and goes, oh, it's a JavaScript test. They're not going to actually go back and look at it for a good 2 or 3 more invocations when it stays red, because they're so used to it being red occasionally. It's it stacks too high, so it's a matter of being able to sort of manage it. One important thing I have to mention here is that with WebDriver, Selenium's improved immensely about this. It still doesn't have the it can't quite figure out when there's a pop-up, but I'm pretty sure, mostly because Simon Stewart knows where I live and he's the primary developer on WebDriver, and he's currently in the country, I'm pretty much required to say, yes, it's improved a great deal. So what do we do to actually fix all of these problems? A new runner, perhaps? It's a thought, right? Now, I'm sure anybody who's actually read through the abstract knows I'm selling something here. Well, maybe. And that's JsTestDriver, which myself and a couple other people got together, and I looked at it, and I could swear there's code in there from 2009, which is kind of scary. Surprised the hell out of me. I would have thought somebody would have killed it off by now. So what JsTestDriver does is it makes a few changes. First off, it's got some key features we thought were very important. So we got rid of the HTML boilerplate. It's a test that's written entirely in JavaScript. It's a test that has a very simple API for actually accessing actually creating the test. It's got explicit declaration of resources because we took the goog.requires. Now, mind you, this is internal. I'm not giving anything away because this is one of those things, but it's internal, and it's actually very easy to write one of these externally. I keep meaning to actually get around to open sourcing it. And what it'll do is it'll look through all the Goog requires, and it figures it out before it ever serves a test what's going on. That's an absolute necessity, is so that when it actually serves a test, the test is written in line, all the files, all dependencies before you even start. So there's none of this document.write shenanigans and the occasional, oops, wait, we put something somewhere else. It's embeddable. Stick it in your IDE, run it off the command line. This means you can get rid of that context switch. No longer is there turn away from your IDE. You can have basically a JUnit interface. We actually have a plugin for Eclipse and IntelliJ. Recently, the IntelliJ team took it over, and I believe they're going to put it in, I don't know, maybe it was like WebStorm. I actually can't keep track of IntelliJ releases. Yes, I'm an Eclipse developer. Or masochist. Let me guess, somebody works for Eclipse here, right? Or works on Eclipse. Oh, good. Scoring better than usual. Guess the browser crash took care of that. It handles the browser caching for you. So this is a key feature. It knows exactly which files have been loaded into the browser. And it knows exactly which files to replace when you make a change in the browser. So if you have a well-behaved test, and by well-behaved test, I mean something that doesn't go out and grab, doesn't leave global state around and so forth. And I'm sure somebody at some point in time has told everybody here that globals are evil. In JavaScript, that's kind of funny because technically everything's global. You can pretty much get anywhere unless you've stuck it inside a closure, and even then it's a little suspect. It will actually update just the pieces. So when you're doing a heavy development section, you're doing sort of classic test-driven development, there isn't a page reload involved. If we ignore Chrome, the reason why I say if we ignore Chrome is because in the last couple of releases, they really actually have managed to match their advertising. I'm sitting here looking at millisecond timings, and Chrome routinely hits in a lot lower than it really has any right to on reloading a page. I'm not saying that because I work for Google. Trust me on this one. It saves a lot of time because you don't reset. So you're saving at least a second or two of loading your JavaScript files and so forth. It also makes sure that all the right headers are sent and does some cache breaking logic to ensure you don't get the same test file twice, which is always fun. And since it's JavaScript, of course, you can sit there and you can, compile it, lint it to your heart's content. Quite a few teams are doing exactly that, and they really love that particular aspect of it. What they're not so fond of is the debugging experience, but I'll get to that in a second. One of the sort of biggest selling points, and this is one of the core pieces of design, besides removing the browser from the equation, is handling multiple browsers. So when you're doing your development, if you can handle the whole piece line of setting it up and actually debugging and paying attention to what your application is doing, say, test-driven development or a lot of good logging, you've got this particular setup where you can start a JsTestDriver server, take multiple browsers. This includes browsers that are not that are hard to set up. So I can take an iPhone browser and I can set it against this particular server. I can take a Mac browser, set it against this particular server. So for development, I know it works. I still don't know if it works with everyone else's code when it gets sent off because we can't virtualize that. But oddly enough, Safari for WinXP has done a pretty good job. So what about the downsides? Because you can't get all this and not have some downsides. Well, the first part is, remember that core concept of taking the browser out of the equation? Well, turns out that not everybody's thrilled about that when they actually need to do debugging and development. Over time, JavaScript developers have developed an almost, a Stockholm syndrome with the browsers. The more the browser beats them up, the more they actually want to keep going back. I mean, it's a fairly classic IDE setup. So in general, people are fairly happy being able to see everything running. They don't quite trust it. You know a good web developer because they actually don't trust anything unless they see it run themselves. They're too used to working, things happening behind their back, which makes a certain amount of sense. You do have to start a server though, in order to run a JsTestDriver test, because of it allows you to do certain things ahead of time. So I'm sure somebody was thinking, wait, you took away the HTML boilerplate, how am I going to write my HTML? Well, there is the, document.append, document.body.append and so forth, or sitting in our HTML on something, but it's a little ugly to work with. So there's a declarative syntax, which is handled by a preprocessor. It's a very easy preprocessor to write, a little bit of Java, a little bit of juice, and suddenly you can add whatever annotations you want inside your code and run through a JsTestDriver instance. This is also, coincidentally, how we got something that we had a very painful time doing inside the closure HTML files, which was getting test coverage. we couldn't actually get coverage for our test because it's running in an HTML file. We had to report information out of the HTML file. And more importantly, if you're loading the dependencies directly, you've got no interstitial place to actually make modifications to your code. Well, JsTestDriver allows you to do that. That was one of the points of it, is that you can go in, you can add plugins to it, you can make it extensible. We have people who've gone in and added asynchronous test case to it. People have written, QUnit and YUnit adapters. I think that was the Y thing. I can't remember Yahoo's. Now, of course, there's one really big problem with it, which is there's last count 241 outstanding bugs in the open source version, mostly because the information, the development is driven by internal needs. So when somebody complains about not being able to, say, glob multiple files, I'm afraid that kind of goes to the back of the list. Not everything's perfect, but this is more or less available to developers now. So, of course, the next question is, how does it scale? Well, one of the things I brought up is when the flakiness comes in, you have that timeout. You don't know what exactly happens with the timeout. Well, now we kind of do, because we have this heartbeat that's going between the server and there. And so what happens is when the browser dies, it gets carried all the way back and reported appropriately to the test run. And it says, your browser panicked. We're not quite sure what happened. Here's the last set of logs. We're really quite sorry. But, you can go take a look at this. The declaration of resources, which I was making a whole big deal about static resources, actually allows us to improve and write different sharding approaches so that we can actually group tests together by what they use, not what we sort of guess they use, and then miss pieces. I still was never able to check that particular piece in. I wrote up a system that would actually take a Clojure HTML test, extract all the particular dependencies, and then attempt to figure out where it should be sharded together and not send those dependencies over the wire. Still failed in a certain number of cases. It's kind of depressing. So that brings us around, and I think we're more or less on time, to the resources. So I've included a couple here. We have the web testing at Google. We have the tools of continuous integration for Google Scale, and of course the Clojure testing tools. I use the URL shortener on the last one because there's really no reason for you to actually attempt to pull down the entire, code.google/blah, blah, blah, blah. It's just not really worth it. And I think we'll move on to questions.
If you want to line up at the microphone so everybody can actually hear you.
Hi. One of the questions is slightly related, slightly unrelated, is how do you feel about JsTestDriver being used for unit test with Node.js? It's something I've started working on recently and haven't really found anything that's spectacular.
I actually have no problem with it. It's something I keep meaning to do. It's not particularly hard to set up. There's been a couple of proof of concepts. Of course, it means I'd actually have to support it. And, I'm a developer, which means I'm extraordinarily lazy. Remember that 241 bugs? I've got something to do in my spare time. But we do take submissions and code and so forth. I've been informed it's actually a fairly easy thing to do to put in. It's like fake DOM or something. There's a DOM replacement that you can load into Node.js, and literally you can load the code that JsTestDriver uses to run inside there, and it acts like an actual browser.
Thank you.
Yes, I had a question about can the Clojure be used for testing and stress testing non-JavaScript pages, maybe like PHP pages, HTML, etc.?
Clojure is basically a bunch of JavaScript libraries. I believe it's a bring your own server approach.
So how does that work?
You start up a Jetty server and you load your HTML file, or did you mean JsTestDriver?
No, Clojure.
Clojure. Yeah, Clojure is strictly JavaScript libraries, and then there's a compiler for it that runs the mixture of, I think it runs mostly in Java. So it really wouldn't be, I can't see how it would exactly be used for stress testing. If you're looking at making like, XHR calls from a browser and so forth to stress test your application, you can look into something like WebDriver for that, or more importantly, you're probably in HTTP unit range, because anytime you want to do mass scaled testing, you probably don't want to start a browser to do your mass scaled testing.
In your presentation, you mentioned about testing like 1 million pages before the code gets submitted, and I was wondering what kind of tools you're using for that kind of stress test.
So the web testing at Google will answer that in finer detail. But what it is they have a system that picks up. So the internal build system, which is the second one, tools for continuous integration, that will. So the web testing manages the VMware, the VM portion of it, as well as starting the browser, and the actual build system, which does the obscene number of builds and tests each day, is sort of a custom Linux-based system to work things out. I don't remember all of exactly what's in there, but definitely watch that talk if you're interested in seeing how that's set up.
Is that going to be later on, or is that?
Oh, no, you see, that's been.
We have
yeah,
it?
it's
Okay.
the second YouTube link.
Okay, I must have missed it. Thanks.
Not so much about the actual tooling, but can you talk about, you said with the mocking and async support, just in general, how you test asynchronous, AJAX UIs, things, extreme weirdness and latency, things like that. How do you really set up those tests for real world use?
It depends how small you're working on it. So if you're working with unit tests, or even just like integration tests of multiple units, then you'd actually look at a unit testing system like I'm talking about. If you're talking about working with a full application, you might want to look into more of the WebDriver system. But back to the unit tests, the way it works is you have, at least in JsTestDriver, and in most cases, like QUnit, I believe, has like stop testing, start testing, and in your callback you need to stick to start testing. I think you can figure out why that doesn't always work so well, especially if an exception goes in. But the fundamental structure is you stop, you basically queue up what's going to happen. So you have your section that makes an asynchronous call or a set timeout call. And that will have, a stop testing right after that's called, because the next JavaScript invocation won't happen until the current JavaScript invocation ends. So you'll say, call foo in 5 minutes, and then you'll say stop testing. And then inside the, foo, when the callback of foo happens, you need to tell it to start testing. So you wrap your function inside that function to resume. In the JsTestDriver asynchronous test case, what it does is it actually creates a queue of functions that need to be called, and it wraps each of these functions inside a something to catch exceptions and so forth, so you actually get a failure instead of a timeout on your test, because that's the biggest problem with asynchronous test cases, is that what happened to make it fail? Well, I don't know. Until recently, it really sucked in Chrome, because actually any WebKit-based browser, because there was no on error. They sort of left that out in the whole setup. On error is a handler that's called whenever there's an uncaught JavaScript exception. Oddly enough, it didn't exist in Chrome until very recently, because somebody finally fixed the bug, which made writing test runners an absolute pain. So what, basically, JsTestDriver's asynchronous system goes through the effort to help make it pleasant, and then tells you which callbacks failed to come back and lets you name the different callbacks. All of the nice stuff that you'd expect from a decent testing system.
Can you talk about languages that get compiled down to JavaScript, like CoffeeScript, Google Web Toolkit, and if there's any integration between what Chrome is going to do with source code mapping?
So that's a little out of my league. I will note that most of the languages to compile down, I haven't looked too deeply into CoffeeScript, but I know Gwt, one of the reasons why it hasn't taken off and you don't see, say, Docs or Gmail written in Gwt is because the abstraction's a little too leaky to actually be successful. But for what's actually happening under the hood of Chrome is unfortunately not something I'm particularly familiar with.
Okay. So with JavaScript kind of being asked to shoulder more of the burden that's been in Flash's domain with SVG and Canvas and more of the rich media, how do you see it changing the way you test JavaScript?
oh, it's just going to get more fun now that they've added, Canvas and all the rich media portions, because now fundamentally, it's not going to change too much. It'll actually improve a certain level, because one of the fun parts about testing UIs in JavaScript was, okay, we think the element's supposed to be over there somewhere, which turned out to be a remarkably vague statement. One of the things that comes up continuously is, oh wait, this test is failing. Why? Well, it turns out Firefox 3.6, when you open it, inside the VM, opens like this. It's like a 10 pixel by 10 pixel window. So most test runners actually set and resize the window size, except they've started disabling that for security issues, because it's annoying when something comes along and pops a window under or resizes and takes over your entire screen with Viagra spam. So it's one of these fun fighting things that comes up continuously in testing, and especially in JavaScript testing, which is what we want to do, which is automate your browser, is also what security does not want you to do. It's also what like privacy doesn't want you to do. They really don't want to give us the access we actually want.
So then with like Canvas, because once you draw it on the canvas, it's lost pretty much. I mean, it's just a bit on the screen. How do you even test that?
SVG is easier, but there is a way to pull things out of Canvas, and the other fun part is you have to figure out what kind of libraries you're using. Ideally, you're using a library that abstracts drawing dots on the screen appropriately, and then you provide it with a suitable mock, and then you just verify that you drew dots at X, Y, and Z. That will be my answer to just about anything which is like, well, we can't get it back. It's like, that's what a mock is for.
Okay, cool. Thanks.
Sure. I think that about covers it.
Yeah, cool. So if there are no other questions, we'll just wrap up the formal QA side now, and feel free to stay around. Like I mentioned in the beginning, there's a bunch of us with Google shirts. If any of you have any questions, feel free to find one of us. Otherwise, thanks, Cory. Thanks very much.